Today we're going to be graphing cosine and sine functions, and if you notice I drew the unit circle on the notes right away before I started the recording, just because we're going to be referring to this as we go through. I'm going to actually be using these points as guidance to help me graph the sine and the cosine functions. So we'll start with cosine, because remember, this should look sort of familiar, but we talked about the fact that when you have a point xy coordinate, we have the cosine value first and then the sine value. So what that means is if I'm graphing cosine, I'm going to be looking at the cosine values as I go through. And I'm also going to be using these, I'm going to add 2 pi to this. I'm also going to be using these angles. So what I'm graphing this as is a series of points that deal with the angle on the new x-axis, and then in this case the value of cosine on the y-axis. So I'm sort of changing up the way my coordinate points are, and then I'll sketch a graph like a curve. So I'm going to start with the basic axis. Now I want you to remember that these can go forever and ever and ever in each direction. And so when we graph the cosine, I'm only going to be graphing what I call one period, or one lap around the unit circle. Sometimes I'll graph more, sometimes I'll graph less, but right now I'm going to do one lap around the unit circle, and then we'll translate that, what happens when I start to change the numbers in front of the angle and change the numbers in front of the cosine. Sort of like when you were in algebra and you graphed a line, and as the slope changed it got steeper or less steep, and as the y-intercept changed it went through a different area on the y-axis. So those kinds of things are going to happen as well. Alright, so what I'm going to do is I'm going to again base my x on the theta, or the angle. So I'll start, here's 0 pi. My first tick mark that beyond 0 is pi over 2, and pi, and 3 pi over 2, and 2 pi. And so I'm going to try and even those out as nicely as possible, because they're evenly spaced on the graph. And again, we could continue and we could add another pi over 2 and add another pi over 2 and add another pi over 2 and keep going. I could get to 4 pi and 8 pi and extend this out. But again, I'm graphing over one period. So when I sketch this graph, 0 pi, I'm going to think about 0 pi cosine is 1. So I put a point at 0, 1. When I go to pi over 2, cosine is 0. So this next point is pi over 2, 0. When I go to pi, cosine is negative 1. So this is up here at 1. This is down here at negative 1. 3 pi over 2 cosine is 0 again. And then at 2 pi, it's 1 again. Now these are curves, so I'm not going to connect these like a straight line V. This doesn't look like an absolute value function. It's a curve, so I'm going to curve this through. Think of this as a circular function, so it's going to curve through. And actually, it's going to continue endlessly in the other direction and continue endlessly to the right as well. But this is the parent function for the cosine over one period. I say that the period, how long it takes for it to repeat itself here, is 2 pi. We also have a height of this function from the x-axis. How far away is the function from the x-axis at the max? And so the max distance from the x-axis is called the amplitude, and the amplitude here is 1. Now the amplitude will change as the number in front of the cosine changes, and the period will change as the number in front of the angle changes. So those are two things that we're going to look at. We're going to go through the same process with sine. This is going to be the picture of cosine that I want you to remember. We're going to go through the same process again with sine. I'm going to draw that circle again and put those points on 0 pi. I'm actually going to pause and do that so you don't have to watch me go through all Okay, so I went through and just redrew that picture. You can do the same, but keep in mind that this time we are interested in the sine, and the sine is the y-coordinate. So I'm going to be only interested in graphing the y-coordinate. Again, this is going to be theta, comma, sine of theta. So when I sketch my graph, I'm going to kind of start it the same way. This is the theta axis, and this is the sine of theta axis. And so it's not necessarily x and y anymore, although this is y equals sine theta, so we could still call this here the y-axis. But I'm going to do my tick points. These are the theta axis values. There's 0 pi at the start, and then pi over 2, and pi, 3 pi over 2, and 2 pi. Again, maxes out at 1 and -1 because there's nothing going on in front of here. And again, it goes to 2 pi because there's nothing going on in front of the angle theta. But now I'll go through and graph my sine. So I'll plot the point at 0, the sine is 0. At pi over 2, the sine is 1. At pi, the sine is 0. 3 pi over 2, the sine is -1. 2 pi, the sine is 0. And again, these aren't sharp, teethy kind of points. These are curves. And these curves, this could continue forever and ever and ever and ever and ever and ever in both directions. And it just repeats itself as we move around the unit circle. But what I'm interested in is this one period of that sine graph. The period here, how long it takes to repeat itself and start all over, notice it would start all over again and continue, is 2 pi. And the amplitude is 1 again. So we're going to see how those things change. Now the parent function doesn't change for these, just the period and the amplitude by adding numbers to the front of the value, and as you move down a little bit, adding numbers to the front of the angle. So this number here is in the A position, and the absolute value of A is the amplitude. So it doesn't matter if it's negative in front of there. That's going to just sort of change, again, the direction that you start in. But A is the absolute amplitude. The absolute value of A is the amplitude. So in this case, the amplitude is 3. But the period doesn't change because nothing changed in front of the angle. So that's still 2 pi. So when I sketch my cosine graph, the period doesn't change. It's still based on those 2 or 4 tick marks that end at 2 pi. But this numbering on the sides changes. This makes this 3 times as tall. And so it tops out at +3, bottoms out at -3. But the cosine function doesn't change. When I graph the cosine function, I'm going to go back to that parent function. I always go back. If you look back at what it looks like, it starts up, then it goes to 0, then it goes down, back to 0, back up. Here's my cosine function. So the only thing that changed, it's like graphing the same exact thing, just the numbers, the scalar numbers that we use are going to be changing. But the cosine is still going to look the same. We're going to do shifts too, where we'll take it and we'll shift it to the left or to the right or up or down. But again, the only thing that'll change is sort of where it is on the graph. The cosine function will always look like the cosine function. Like I mentioned, if you stick something in front of the angle, it's going to change the period. This is B. Oops, stay there. B. Okay? And the period is equal to 2 pi over B. What happens is when you change this number, that means that I will get 2 sine graphs in the original amount of time, in 2 pi. So if I want to know how long it's going to repeat itself once, I would go ahead and in this case I would do 2 pi divided by 2, and it's going to repeat itself in pi. So when I sketch my graph, this end number here is not 2 pi, but pi. But I still have to base it on the 4 marks. So I have to figure out how I'm going to number the rest of these. Now nothing changed on the amplitude, so I'll stick that in there now, and now I want to figure out these numbers. So for me, the easiest thing to do, and everybody kind of has their own way to do it, but for me the easiest thing is to start at the halfway mark. Half of the period is pi over 2, and then I'll cut that in half. And that's just doubling the denominator, reduce if possible. So now these should be even intervals. So I can just count. This is 1 pi over 4 and 2 pi over 4, which reduces to pi over 2. So the next one has to be 3 pi over 4, and the last one would be 4 pi over 4. Another thing I've seen people do is I've watched them add these two together. Pi over 4 plus pi over 2 is 3 pi over 4. So whatever works for you. But once I get there, then I can go ahead and graph my sine graph. And so it starts at 0, and just going back to the original. If you need to look back at it, go ahead and look back at it. But I always do the point method, and I recommend that you do it the same too, where you actually make the 5 points as you work around the circle. That way you have guidance there. Otherwise, sometimes if you're just trying to sketch it without putting the points on there, people kind of get a little wonky when they get their graph going. So I just recommend that you use the 5-point method to get that graph on there, and then you can sketch your sine on. Okay? So now we're going to work through a few more. Again, the cosine function and the sine function aren't going to change. What we're going to do is we're going to be changing both the amplitude and the period in the function. So I'm working with a cosine function. In this problem, my amplitude is the absolute value of 2, which is 2. But this is a little weird. So I want you to look at that and think of that as 1/2 theta. That's just a different way of writing 1/2 times theta. So when I do the formula for the period, which is 2 pi over b, I'm going to do 2 pi over 1/2, which when I divide 2 by 1/2, I get 4 pi. How many halves fit in 2? 4. 2 divided by 1/2, 4 pi. So when I sketch my cosine graph, it tops out at 2, bottoms out at -2. I'm still going to use those same 4 tick marks. I base them off the 4 quadrants. That's why there's those 4 tick marks. That's where we started. The parent function took up until 2 pi, 1 lap around the unit circle. But when we start adjusting the angles, now this one's going to end at 4 pi. So I'm going to number through. Half of that is 2. Half of 2 is 1. And then I just count. 1 pi, 2 pi, 3 pi, 4 pi. Once I have that done, I do the 5-point method of sketching the function, the parent function, based off the original cosine graph, and connect my points. Kind of the same thing each problem. So I'm going to do one more, problem number 6 with you, and then I'm going to pause and have you try 7 and 8, and then I will work through those problems while you're paused. Again, you can pause at any time and stop and look back at the problems, but I'll finish those problems, and then you can check and see how you did. So 6 will be the last one we do together, and then 7 and 8 you're going to try on your own. So for number 6, I have an amplitude, I'm going to abbreviate that, amplitude of 2, a period, abbreviate that, of 2 pi over 3. Remember, this number here is b. The period here for sine and cosine is 2 pi over b. The period is how long it takes to repeat itself. So in this case, it's 2 pi over 3. I can't reduce that. So what that tells me is 1, 2, 3, 4. This last one is 2 pi over 3. Tops out at 2, bottoms out at -2. -2, not -3. That's a -2. Okay. Just erase it, hand. Instead of scribbling over it. So -2. All right, so this is where people struggle a little bit. Just cut it in half. Half of 2 pi over 3 is 2 pi over 6. So 2 pi over 6 reduces down to 1 pi over 3. So it was cut it in half, double the denominator and reduce it. cut it in half, double the denominator, and reduce if possible. I can't reduce that, so pi over 6. Then I just count. So 1 pi over 6, 2 pi over 6, reduced down to pi over 3. 3 pi over 6 reduces down to pi over 2. And then 4 pi over 6 reduces down to 2 pi over 3. I'm graphing the sine function. Sine function starts at 0, so I do my 5-point method of graphing and sketch it in. Okay, so again, I am going to pause right now. I'm going to have you try 7 and 8, and when you're finished, hit play again, and I will have my graphs, and we can kind of compare and see how you did. Okay, so here are my completed graphs. In number 7, the amplitude was 1/2, so it topped out and bottomed out. Topped out at 1/2, bottomed out at -1/2. Period was 2 pi over 2. It came from this value right here in front of the theta. So I reduced that down to pi. Pi came first. I cut it in half to get the middle, cut that in half, double the denominator to get the first tick mark, and then I just counted and sketched my cosine. Likewise for number 8, the funny thing was this thing here. Pi or theta over 4 is like 1/4 theta, so my b is 1/4. That's the b part of it. And so I have to figure out how many fourths I can fit into 2, or 2 divided by 1/4. That's 8 pi. Put it on the bottom here, and tick mark was 8 pi. Cut it in half to get 4 pi. Cut that in half to get 2 pi. 2 pi, 4 pi, 6 pi, 8 pi. So hopefully you did all right on those. Our next graphing that we'll do in class will be with phase shifts. That means we're going to shift our sine and cosine function to the left or to the right, or vertical shifts where we shift it up and down. So other funky things are going to happen as we go through here. But what I'd like you to do for homework, and I'm doing the homework a little bit different this time, I want you to do section 2-4 in your note packet that we're going to change to section 2.3 if you didn't do that already. I want you to do 69 through 72 all, and then you can do 77 to 96 evens or odds. 77 to 96 evens or odds. So that's the assignment, a little bit different than what I usually do because I sort of adjusted how we set up our homework assignment. But as always, come with questions tomorrow when you come to class, and then we'll continue on. I hope you have a great day.